Hi folks, today I'm going to be talking about Gaia, which is a European Space Agency space probe orbiting about 1.5 million kilometers away at Lagrange point 2. You can see on this chart where Lagrange point 2 is relative to the Earth-Moon system. It's quite far away, and it serves as a gravitationally stable point for the spacecraft to orbit. However, because it is so far away, it's normally quite difficult to observe. But on March 6th, as part of the commissioning process, they turned the spacecraft such that this reflective surface started reflecting light towards Earth. However, on March 7th, they turned the spacecraft back to its original orientation, and as a result, this surface no longer reflects sunlight towards Earth. In fact, this surface here acts as a shield to block sunlight from the spacecraft, so it can continuously observe about 1 billion celestial objects down to about magnitude 20. Gaia is the successor to the successful Hipparcos mission. But whereas Hipparcos only observed about 2.5 million stars down to about magnitude 11, Gaia will observe 1 billion stars and galaxies down to about magnitude 20, and very accurately chart their positions. It's an astrometry mission. Its objective is to very carefully measure the positions and motions of stars in the sky. And we're going to talk a bit more about astrometry in a moment. But first, I'm going to show you the images I collected using a telescope in Australia during the spacecraft's turn on March 7th away from Earth. And as you can see, initially, the spacecraft reflected quite a bit of light and looks like a fairly bright star, but it very rapidly dims as the spacecraft turns away from Earth. And you can see the chart of the relative flux relative to some other stars in the image over time, and you can see it initially increases a little bit, but then it very dramatically drops off till the relative flux reaches basically zero. In other words, too dim for the telescope to detect. So, as I mentioned before, Gaia's mission is an astrometry mission. Its mission is to observe stars down to about magnitude 20 and chart their positions. And this will give us a massive star catalog. And using that star catalog, we can measure the positions of objects in space. Astrometry is useful to a wide variety of fields in astronomy. Basically, any time you need to measure the position of an object in space. So this is data that will be useful to professional as well as amateur astronomers. For instance, let's say you want to know what this object is. Another YouTuber pointed this object out in the stereo ahead HI2 images, and he thinks it's a Comet linear. Well, we can find out what it actually is. He's got this arrow pointing to the object of interest here, so we can actually astrometrically solve this image. Now, obviously, Gaia hasn't completed its mission yet, it's just started. But the Hipparcos mission that Gaia is the successor to has completed its mission, and from that we have the Tycho 2 catalog. So we can use that catalog to astrometrically solve this image. We can see all these stars in the image, so we can use that for astrometrically solving it. And we have that here. So this image has been astrometrically solved using the Hipparcos data, and we can see the coordinates of the center of the image, the size of the image, all this wonderful data given to us because of the Hipparcos mission. Gaia's mission is the successor to this. It will give us many more stars, so we can solve to an even higher level of precision and with much smaller fields of view. But the stereo spacecraft use wide field cameras for the heliospheric imagers, and so they're actually quite easy to solve even with Hipparcos data. And you can see the Astrometric Solution here. You can download this WCS embedded FITS image here, and this will allow us to determine the coordinates of the comet within the image. So let me pull that up. So here's the comet being pointed out in the image, and we can get the coordinates for it. So there we go. So using Hipparcos data, we have coordinates of 13 hours, bright ascension, 35 minutes, and about 16 and a half degrees declination. So now we know where the comet was as seen from the perspective of stereo ahead. So we can simply look up what comet should be there at those coordinates from the perspective of stereo ahead. And I have that here, and it turns out it's actually Comet Lovejoy, C2013 R1 Lovejoy. And you can do this for just about anything you see, whether it's from Earth or from stereo. It's wonderful. As long as you have an image that has stars in it, you can astrometrically solve it. So we have another image here for astrometrically solving. We have an image here of an asteroid, and Again, another YouTuber is wondering, what is this asteroid? It seems to be coming up towards Earth in the image. Is it something we should be worried about? So let's figure out what it is. Here's the Astrometric Solution. Once again, I've downloaded the WCS embedded raw FITS file. Actually, it's not really a raw FITS file. It's a FITS file generated from the JPEG from his video. But you can use raw FITS files as well, and that works quite nice too. So you can just dump your images straight from your telescope onto astrometry.net and use the Hipparcos data to figure out what the coordinates are. Now, in this case, we have the coordinates of this asteroid here, and they are 10 hours, 50 minutes right ascension, -1 degrees, about -1.25 degrees, or -1 degree, about 14 minutes declination. So we can figure out, once again, by looking from the perspective, in this case, from stereo behind, what should be at those coordinates. And we see that at those coordinates is the asteroid Pallas, another very well-known asteroid. And once again, you can see that this corresponds to the image we were just looking at. We have Earth up here and Pallas down here. Earth up there, Pallas down there. So once again, we've identified the image using astrometry. That is what astrometry is useful for. That and just about any application where you need to know what the coordinates of an object are in space. And so it's a very handy tool to have, both for identification and for tracking of unknown objects. In this case, both the objects are well known. So that's that, and I hope you all have a nice day.